Hi, I'm Miss Hanson, and today I'm doing a lesson overview of the quadratic formula. Now, quadratic formula is just another way to solve a quadratic equation. We've learned how to factor to solve quadratic equations and how to use completing the square to solve quadratic equations, and now we're going to talk about the quadratic formula. The quadratic formula can be used for any quadratic equation, and it's really nice because you're just plugging numbers into a formula. So let's get started. When we're using the quadratic formula, we want to make sure everything is on one side of the equation and it equals 0. So you're going to set it up just like you did when we were factoring. You want everything on one side and the other side equals 0. Then we're going to identify our a, b, and c. And last, we're going to plug into the quadratic formula and simplify. Now, identifying a, b, and c, a is always the coefficient that goes with x squared, b is always the coefficient that goes with x, and c is always your constant. When it's set equal to 0, that's how you find your a, b, and c. Okay, so let's do some examples. Okay, here's our first example. 3x squared plus 2x minus 8 equals 0. Well, it's already set up right. We have everything on one side equaling 0, and we just need to find what a and b and c are. A is 3, it's the coefficient of x squared. B is the coefficient of x, so it's 2, and c is negative 8. Okay, now we're just going to plug it into this formula. That's the nice thing about the quadratic formula is the formula never changes. Okay, so it's x equals negative b, so negative 2, plus or minus square root b squared, so 2 squared, minus 4 times a times c. All of that over 2a. And now we just need to simplify. So it's negative 2 plus or minus square root 4, and here we've got minus 12. Well, 4 times 3 times 8 gives us 96, right? 12 times 8, 96. And there's a negative and a negative, so it turns into a plus. All of that over 6. So we get negative 2 plus or minus square root of 100 over 6. So negative 2 plus or minus 10 over 6. Now this one's nice and easy to solve, so you should go ahead and solve it if you can. So we get negative 2 plus 10 over 6, so that's 8 over 6, or 4/3. And then we have negative 2 minus 10 over 6, which is negative 2 minus 10, negative 12 over 6, which is negative 2. So those are your two answers. Okay? Sometimes we're going to get a number in the square root that doesn't simplify as easily, and that's okay. We can leave it under the square root. We always want it in simplified form, but it doesn't have to be in decimal form. We can get it nice and simplified without that. Okay? So here's our next example. I want you to think about what is the first step you're going to do. Is the first step going to be to identify a, b, and c? Is the first step going to be to move negative 5 over? Or is the first step going to be divide everything by 2? So think about it and make your choice, and then we'll move on. Okay, our first step is going to be to move that negative 5 over. So we want to get it to be 2x squared minus 3x plus 5 equals 0. So I just move the negative 5 over, so it now equals 0. Now I can find out what a is. A is 2, b is negative 3, and c is positive 5. And now we can plug it all into our quadratic formula and solve. Okay, quadratic formula is x equals, I want to use a different color, negative b. So we already have a negative 3, so if we're going to do negative b, it should be a negative negative 3, so a positive 3, plus or minus square root b squared minus 4 a c, all of that over 2a. Okay, now we're going to reduce 3 plus or minus square root 9. Minus 4 times 2 is minus 8 times 5 is minus 40. All of that over 4. So 3 plus or minus square root of negative 31 over 4. We can simplify that one more step. 3 plus or minus I root 31 over 4. Okay, don't forget to take that I out if you can. If we could simplify it any further, we would. Okay, so that's your final answer. That's actually your final answers, because remember, plus or minus means it's actually two answers. 3 plus I root 31 over 4, and 3 minus I root 31 over 4. Okay? Now we're going to talk about the discriminant. The discriminant is an important part of the quadratic formula, and it helps people tell what kind of roots they're going to have without actually having to go through and find the roots. So if you just wanted to know like where it was going to cross the x-axis, whether it was going to be a rational number or an imaginary number, that's what you use the discriminant, okay? The discriminant is the part under the square root sign, the b squared minus 4ac, without the square root sign, just those numbers, okay? It tells you what kind of roots you're going to have. So let's look at the different things it can tell you. If it's positive, if it's greater than 0, b squared minus 4ac is greater than 0, you have two real roots. That means your graph is going to cross the x-axis twice, okay? If it's a perfect square, they're going to be rational numbers, okay? Remember, rational numbers, anything that can be written as a fraction. If it's not a perfect square, oops, I should have written not perfect square there, then they will be irrational roots. Irrational roots are those numbers that are non-repeating, non-terminating decimals, okay? So that's what it means if it's positive. If the discriminant equals 0, there's one real rational root. And what that means graphically, that's when the graph comes down, touches the x-axis, and comes back up. It doesn't actually cross. Okay, that's called a double root, or in this case, when it equals 0, it's one real rational root. Okay, and the last combination you could have is if the discriminant is negative. And then, as you know, the square root of a negative gives you two complex roots. And the graph would look like, if it's complex roots, the graph would be one of those that never crosses the x-axis. So then the roots are imaginary. They're complex numbers. Okay, complex numbers, remember, means imaginary part plus a real part. Okay, so the type of problem you might see having to do with the discriminant would be something like this. Describe the roots of the following without using quadratic formula. So that means you're going to find the discriminant, which is b squared minus 4ac. And we're going to see whether it's greater than 0, less than 0, or equal to 0. So let's find what b is, or a. Well, let's find all of our letters. Okay, so here, a is 3, b is negative 5, and c is 4. So b squared is 25 minus 4 times 3 times 4. So we got 25 minus 48. 25 minus 48 is negative 23. So that's negative. It's less than 0, right? So that would give us this situation where we have two complex roots. Okay? So that would be where the graph doesn't cross the x-axis at all. Here's our second example. Let's find our a, b, and c again. A is 2, b is negative 5, c is 2. And let's plug them into our whoops, wrong pen. Ew. B squared minus 4ac. So we're going to plug in b is negative 5, so we get 25 minus 4 times 2 times 2. So 25 minus 4 times 2 times 2 is 16, right? 25 minus 16 is 9. So that's greater than 0, so we know there are two real roots. And it's a perfect square. So we know it's two real rational roots. If it wasn't a perfect square, they'd be irrational. And think about it, that means that if it's a perfect square, then when you put that under the square root in your quadratic formula, you're going to come out with an answer that has no weird decimals in it. I want to erase that little b there. Okay, so that's why. So that's how the quadratic formula and the discriminant work. So you're ready to get started on the homework problems. Have fun with it. Good luck, and I'll see you next time.